Hi everyone, welcome back. So I'm going to talk about mixtures in this video. Just a quick review from the last video. We already learned about elements, and we learned that elements are represented by chemical symbols like this one here. So capital N, lowercase a represents this element, sodium. And then capital H represents this element, hydrogen. We learned that a molecule is two or more of the same elements chemically combined, or two or more different elements chemically combined. So O2 is an example of a molecule. Sodium chloride is another example of a molecule where we have one atom of sodium, one atom of chlorine chemically combined. And then compounds we learned had to be two or more different elements chemically combined in a set ratio. So sodium chloride again, since it's two different elements, sodium and chlorine, that's a compound. And then water is also a compound because we have two atoms of hydrogen chemically combined with one atom of oxygen. So what is a mixture? And why are mixtures different than compounds or molecules? So mixtures can be made up of either single atoms of elements, different elements mixed together. It can be made up of different molecules mixed together, or it can be made up of different compounds mixed together. But what's important to remember about mixtures is the separate compounds and mixtures aren't chemically combined together. So I'm going to give you an example. Salt water is actually a really good example of a compound. So I'm going to clear my board here and erase and make some room for us to work. So salt water contains two different compounds, obviously, salt, or sodium chloride, and water mixed together. So I'm just going to draw a dashed line to start. I'm not mixing these two together yet. What I'm going to do is just place a few compounds of salt here and a few compounds of water on this side. So in order to create salt again, I need sodium and chlorine chemically combined. That little dash in the center represents the fact that these are chemically combined. And then I'm going to put a few water molecules on this side. So I have my H2O, another H2O, two hydrogens, one oxygen, and another H2O. So right now, this is not a mixture because I have my individual compounds of sodium over here and my individual compounds of water over here. The sodium and the chloride are chemically combined to create a compound. Sodium and chlorine are chemically combined to create a compound of sodium chloride. And the hydrogen and oxygen are chemically combined to create a compound of water. But this is not a mixture. This is just a bunch of sodium compounds together, sodium chloride compounds together. So this would be like this plate of table salt here. Okay, so just a bunch of salt crystals together. It's not a mixture. It's all the same. And then on this side, this is just like a glass of water. So you just have a bunch of H2O molecules floating around, simple glass of water. However, if I decide that I'm going to mix my sodium chloride together with my H2O, then I've created a mixture. The sodium chloride and the H2O are not combining together chemically. The sodium chloride crystals will dissolve in the water, but you can still separate them out later. So what I'm going to do is I'm going to pour my salt into my water and stir it around. And now what I've done is created a mixture, a salt water mixture. And even though once you stir it, you can't see the individual salt crystals, if you mix it together really well, the salt crystals are still there and they're separate from the water molecules. So how would I separate the salt back out? Remember I said chemical compounds are really hard to break down. Mixtures, not so much. They're a little bit easier to break down than any chemical compounds. So I could actually evaporate the water. And if I evaporated the water, I'd be left with the salt crystals at the bottom of the glass. So that's a mixture. So to represent this here, all I'm going to do is move around some of my sodium chloride compounds. I'm going to forget my lines for now for the chemical bonds. Just imagine that they're there. And I'm just gonna start mixing things together. So just start mixing this in. So I'm mixing my salt and I'm mixing my water. So even though I have separate compounds in this mixture, because they're together in one glass, I've now created a mixture. So the sodium chloride compounds are not chemically combining with the water compounds, but they're mixed together. So they're dissolved into the water. So I hope that makes sense. So one other thing that I just want to show you or talk about is the fact that there are two different types of mixtures. One is called a homogeneous mixture. And one is called a heterogeneous mixture. So the homogeneous mixture would be the salt water. If you've ever heard of homogenized milk, that's an example of a homogeneous mixture. It just means that all the parts, the fatty layer, the liquid layer, are all mixed together. So here, the salt is mixed in with the water, and you can't see the individual components. So if you can't readily see the individual components, you should know right away that this is a homogeneous mixture. Lemonade, the powdered lemonade, or Crystal Light, or Kool-Aid, put into water, dissolved into water, another example of a homogeneous mixture. A heterogeneous mixture is a mixture where you can see the individual parts or the individual components. This would be an example of a heterogeneous mixture because I can see the individual parts. So I have Fruit Loops mixed in with these wheat thins here. A salad would be an example, a pizza, taco, all examples of heterogeneous mixtures where you can see the individual parts. If you have any questions, save them for our Zoom meet. It was great lecturing you guys over this video, and I will see you later. Bye, everyone.